Problem Introduction. Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 15, threesome. This is a classic medium difficulty problem that often shows up in coding interviews, so mastering it is a great way to boost your skills. The problem statement is simple. Given an integer array nums, return all the unique triplets, nums of I, nums of j, nums of k, such that I does not equal j, I does not equal k, j does not equal k, and nums of I plus nums of j plus nums of k equals 0. So we're looking for combinations of three numbers in the array that add up to 0. Seems straightforward, right? But the challenge lies in finding an efficient solution, especially when dealing with large input arrays. We'll explore different approaches, starting with a simple brute force method, then moving on to a much more optimized solution. Get ready, because we're diving in. Understanding with examples. Let's solidify our understanding with a couple of examples. Imagine we have the array -1, 0, 1, 2, -1, -4. Our goal is to find all unique triplets that sum up to 0. One such triplet is -1, 0, 1, because -1 plus 0 plus 1 equals 0. Another triplet is -1, -1, 2, since -1 plus -1 plus 2 also equals 0. Notice that we only include unique triplets. We don't count -1, 0, 1 multiple times, even if the array contains multiple -1s and 1s. Let's try another example. 0, 1, 1. Here, we only have one triplet that satisfies our condition, which is 0, -1, 1. Understanding these examples will be key to grasping the logic behind our efficient algorithm. So, are you ready to see how we can solve this efficiently? Brute force approach. A naive approach would be brute force. We could iterate through all possible combinations of three numbers in the array and check if their sum is 0. This would involve three nested loops, giving us a time complexity of O of n cubed. While this works for small arrays, it's terribly inefficient for larger ones. Imagine an array with 1,000 elements. The number of computations would explode. This highlights the importance of finding a better algorithm. So let's move on to a much more optimized solution that significantly reduces the computational burden. We'll achieve this using a two-pointer technique and a little bit of sorting magic. But before we dive into the optimized algorithm, I'd encourage you to hit the like button if you are finding the content useful so far. Optimal solution. Our optimal solution involves sorting the array first. This allows us to use a two-pointer approach for efficient searching. We iterate through the sorted array. For each element, we treat it as the first element of our potential triplet. Then we use two pointers, one at the element after the current element and the other at the end of the array. We adjust the pointers inward depending on whether the sum of the triplet is less than, greater than, or equal to 0. This drastically reduces the time complexity. The key insight is that by sorting, we can eliminate many unnecessary checks and make the whole process far more efficient. We'll see exactly how this works when we implement the code. Code implementation. Let's see the code in Python. First, we sort the input array nums. Then we iterate through the array. For each number, we set up our two pointers. We check the sum. If it's 0, we add the triplet to our result list, ensuring uniqueness. If the sum is less than 0, we move our right pointer to the right to increase the sum. If the sum is greater than 0, we move our left pointer to the left to decrease the sum. We continue this process until the pointers cross. This elegant approach dramatically improves performance. I'll put the full and annotated code in the description below, so make sure to check it out. Now that we've seen the implementation, let's discuss its efficiency. Time and space complexity. The time complexity of our optimized solution is O of n squared, a massive improvement over the O of n cubed of the brute force approach. The initial sorting takes O of n log n, but this is dominated by the nested loops O of n squared. Space complexity is O of 1 because we're not using any auxiliary data structures that scale with the input size. We're just using a few variables to keep track of pointers and our results. This highlights how a well-chosen algorithm can significantly improve efficiency. This solution is much more efficient and scalable. Engagement break. So, what did you think of that solution? Let me know in the comments below. And if you found this video helpful, don't forget to smash that like button and subscribe to the channel for more LeetCode tutorials. Also, share this video with your friends who are also preparing for coding interviews. It could really help them out. Let's keep this community growing. Conclusion. In this video, we cracked the LeetCode threesome problem, moving from a naive brute force approach to a highly optimized solution using a two-pointer technique after sorting the input array. We achieved a time